Good afternoon. Thank you for choosing to come to this room. I recognise you've got a choice, and I appreciate the fact you chose to come here. Can you hear me okay?
Yes.
Yep. I'm talking about the volume. I can't do anything about my accent. You're just going to have to suffer that for 30 minutes. So I suppose I should explain a little bit about who I am so you can understand who this guy is that's taken 40 minutes of your life. So look, I'm originally an engineer, and I've spent the last 25 years working in infrastructure and technology, a pretty strange mix. But the last 15 years of that has probably been leading people, projects, including large projects, portfolios, and programs of work. But it was an opportunity from earlier in my career that I drew upon when I recognised something that could be done to make projects better. About 20 years ago, as an engineer in Scotland, I used to work in AI using machine learning. Fast forward to today, and I spent a lot of time working on something which I'm hopefully keen to share with you and should make projects a little bit more predictable. So imagine, if you will, using Google Maps to get somewhere. It doesn't consider the traffic, gives you the least direct route, and the so-called 30-minute journey is more like 60 minutes. And this happens over and over again. It'd be frustrating. And in fact, you probably can't imagine it, because I'm pretty sure most of you would delete that app off your phone if it did that. And yet, this is what happens too often on most of our projects. And we've been putting up for it for far too long. So I'm excited to share the work as a founder of Bitwinder that we've done in this space with using AI to make projects more predictable. First, I'm going to have to unpack the problem pretty deeply, and then we'll get to the AI part. So bear with me while we work through that. Projects usually make the headlines for the wrong reasons. I've purposely taken the company names off this. I'll leave it to you to decide if you can guess where they belong. A $15 billion blowout on an energy project, another $20 billion of public money for a nationwide project, and a battle over a $2 billion blowout on a large infrastructure project. These headlines aren't here because they're unique. In fact, they're here because there's lots of them. When I chose to look up what headlines to select, there was many, many to choose from. And people in glass houses shouldn't throw stones, because I've added way too many zeros to projects that I'd like to share. Let's look at what others in the industry are saying about it. So McKinsey, they've recognised that projects over $1 billion are generally 1 year behind and 30% over schedule. I don't think that's a surprise, and in fact, I would say it's actually a bit conservative. EY, they did a study of 365 oil and gas projects. That's not a small study. They found that 64% were in cost overrun and 73% were in schedule delay. But the last piece of research I'll probably draw on was born right here in Australia. And it's the piece that I actually go to mostly. This was a study done by the Grattan Institute, and in fact, I believe it was actually presented at this very conference last year by one of the authors, Marion Terrell. There's three reasons why I draw on this research. Firstly, it was a study of 836 projects going back over 15 years, and these are large transport infrastructure projects. To my knowledge, there's never been another study of its kind of this size ever done here in Australia. So that was completed in 2016. The second point is the study is extremely transparent in its methodology and how it calculated its findings and the recommendations, and including all the data. But probably most importantly, to my knowledge, Grattan Institute don't provide project management services. There's nothing for them to gain in the outcome of this study. So it's as independent as you're going to get. So what did they find? Well, projects over 20 million, 34% of them overrun their budget. Probably no big surprise. They discovered that the average overrun is somewhere between 24 to 43%. Now, the reason for the range is there's some missing data. If you assume the missing data was all great, it's 24%. If you assume the missing data is probably more like the rest of the data, it's 43%. I'm putting my money on closer to 43%. Projects over 100 million, they found that 65% of them overrun their budget, and the average overrun is 52%. Now, I don't know if you can recall from the previous slide, EY noted that it was 64%. So 64, 65, there's definitely a strong correlation between two large independent studies there. And I think probably most people in this room, those first couple of points probably aren't groundbreaking news. Project people probably have got a reasonably good handle on this. But the last point was something that was news to me. They had a look at the P90, so the near worst case estimate, and the P50, so the most likely estimate for projects, and they discovered when you looked through the projects, the difference between those two was only 9.2%. So generally speaking, before a project starts, we look at how bad it could be, and then we consider what it's likely to be, and we think, you know what, the worst case scenario, probably about 10% is all we need to get, to get this completed. But then we went back and actually looked at those projects that had completed and discovered it was actually 26%. So we're not, when it comes to trying to estimate the difference between what's likely to happen and how bad it could be, we're not very good at all. So leading into where this is taking us, what can we draw from this that we could use AI for to try and make this situation better? Well, they found that reference class forecasting from historical projects could help make future project estimates more accurate. Kind of makes sense, and probably for two main reasons. First off, historical project data, it incorporates everything we did know, but more importantly, everything we didn't know. Now, that's factual, because it's actually what's happened. It's not opinion-based, it's very factual. And that kind of leads into the second point. It doesn't suffer from optimism bias. People have got bosses, they've got promotions to worry about, they've got bonuses, they've got job security. All that plays in to how figures are presented at the end of the day. When you're using a process that doesn't care about those things, you reduce the opportunity for optimism bias. And that's something that AI is brilliant at. So I'm going to lead us through a problem here, and we're going to get to some real data that just takes us a little bit further. I'd just like to step through. This is a fictional example, then we'll talk about a real one. Imagine you've got $1 billion to spend over 12 months. This isn't a project, it's a portfolio. 4 months pass, you haven't quite hit your plan. So that's orange is the actual line down there, grey being the plan. Sorry, blue being the plan. Don't worry about it. We're going to reforecast and we're going to get back on track. I'm pretty sure we know this. Another 4 months passes. We didn't quite nail it, but you know what? It's all good. We're going to reforecast and we'll be back on track. We get to the end of the financial year, and lo and behold, we more or less spent what we said we did. Happy days. But remember, I said this was a portfolio, not a project, and they're very different. Portfolios are artificial constructs. They're designed to be measured in a slice of time, whereas projects have genuine, real start and stop dates. Portfolios don't. So what usually happens round about now is we recognise that whilst the underruns might have lent money to the overruns, all they did was lend the money. And if you think about it, it's just lending. An underrun usually is an underrun because the work's not been done. It's usually not because we've done it cheaper. Eventually, those projects have to be completed. So what happens? That work carries over into the next financial year. I call portfolios a magical device. If you want to disguise a loss of value, they're the best vehicle I know. You can really pull it off quite easily. And in fact, if you're good at how you spin it, you can even make that carryover look like you've got a head start in the next year. So by the time those extension costs kick in and those overrun costs, you're looking at another 6 months in this example and another 220 million. And this plays out a lot. And I researched a lot of public domain portfolios and looked at this, and I actually just discussed it with someone earlier. I was staggered to find that we've got the same issue happening in Australia, but almost identical figures in the United States. So it's not something that's just confined to one place or one organisation. So this is a real data example. I've taken the organisation's name off this. It is in the public domain, so I'm not sharing something I shouldn't be, but I'm not here to name and shame. So this was a portfolio, and just like that example, it actually looked like it was going to spend pretty much exactly what it said it did. But when I stepped inside the figures, I started looking at the variance. So how much did they actually spend relative to what they'd actually approved their spend? So the forecast versus the actual. And you can see here that only 8 were within plus or minus 10%. But if you looked at the numbers from the outside, that portfolio looked like it was going really well. Why am I saying this? Why does it matter? Well, I would argue that poor predictability is one of the first indicators of a poor outcome. Not in all cases. Sometimes you can have wild swings in projects and sometimes they can work out okay. But more often than not, if you don't know what's going to happen, unless you're lucky, chances are it's not going to end well. And that's exactly what the case was of this. So I stepped inside and I started to look at what's actually happening inside this project portfolio. What's the status? I found out those 43 projects within that program, 19 were on track, 7 were in cost overrun, 11 were late, and 6 were in cost overrun and late. Interesting enough, I would argue that the 6 that are in cost overrun and late are probably the most honest ones in that portfolio, because as I've discovered, a cost overrun is usually just a cost underrun is usually just a cost overrun that's not happened yet. When things don't start quickly enough and when they don't get up to speed, they generally take longer to complete, and it's really hard to make a project finish in budget if it's taking longer than it was meant to. Now, here's something I found was absolutely fascinating. I calculated the approved total spend, the actual total spend, and I had to look at the variance. Guess what? It was 26%. Exactly what Grant Institute found. So I've found the same figures keep popping up time and time again, so this isn't just my imagination. So, a big lesson to be learned amongst all that data, and what can we do with it? Well, last part to discuss the problem here, let's have a look at what we did last year in Australia. So it's a staggering amount of money. If you have a look at what we spent publicly and privately, we actually are estimated to have spent about $102 billion in capital. That's a mammoth figure. If you use Grattan Institute's figures of, say, we go over budget, 34% of them go over budget by 43%, that's an additional, $16 billion. Now, what can you buy for $16 billion? I did actually look at what you could buy for $16 billion. That gets you 10 public hospitals, major ones. It wouldn't be so bad if it wasn't for the fact that, we do it every year. But silver lining could be, you could say we've just bought $16 billion worth of lessons learned. But no, and that is actually the crux of the problem. We don't learn it. In fact, we have no way to learn it. We will do this again next year and the year after and the year after. And I don't know about you, but it kind of makes me a bit cranky when I think about it being public money especially. There's got to be a better way. And there is, because there's other industries have already learned how to learn and make things better. And that's where I'd like to go to next. At the start of this, I talked about Google. Let's go back to mapping applications and just make a comparison. Mapping applications, they predict journey time and route, but they learn from all the previous journeys. So every time you take a journey, that data is used to help make the next journey a bit more predictable. So as a result of all that data that's captured, they use predictive analytics for predictive modeling. And as a result, the measured average error is around about 6%. That's drawing on studies that I could find. By contrast, our project software, it forecasts time and cost, but it doesn't automatically consider previous projects. Other than lessons learned and what we've pulled in, there is no mechanism to automatically identify with previous projects. It uses a schedule-based forecast that perhaps might be resource-loaded. And if you look at the data we've just found, for projects over 100 million, it's got a measured average error of 34%. That's the figure you get if you get 65% of projects over budget by an average of 52%. So you can see we're not doing what others are doing, and we're getting the outcome that we're getting. And it's clearly something we can do something about. So before we go on this journey into the part you probably came for, the artificial intelligence part, I'd like to go through a few basics to try and make sure we're all on the same page and help demystify this a little bit. Because if there's one thing that AI suffers from, it's hype and mystique, and neither of those things really help. First thing, what are we talking about when we talk about AI and machine learning and deep learning? Well, AI is actually a field of study. It's not a technology. It's been around for a long time, and the phrase was kind of coined in the 1950s there. And in fact, one of the first examples of AI, it was nothing to do with a computer. It was a machine they developed which could actually play chess. So any activity which generally requires a human intelligence to perform, if we manage to find an alternative mechanized or automated way to achieve that, it's considered to be artificial intelligence. So it's really a broad general term. What's more interesting for my discussion today is machine learning and specifically deep learning. Now, as you'll see in a second, deep learning is just a type of machine learning. So machine learning, been around since the 1980s. I first got to grips with it in the 1990s where I studied it and I got a chance to deploy it as part of my job. The basic machine learning from back then, it required extremely strong understanding of the problem and how it related to the data. So you could certainly get amazing outcomes with it, especially using things like neural networks, but you really needed to prepare the data in such a way that you would get the outcome you expected. In a lot of cases, it was actually more hassle than it was worth, to be quite honest. And since 2010, deep learning's arrived. There is a bit of hype around about deep learning, but it really is a bit of a step change in what's been achieved since the basic machine learning. So we've got new algorithms, things like recurrent neural networks, convolutional neural networks, to name but a few. But the amazing thing about deep learning is, whereas before we really had to understand the problem really well so we could prepare the data, deep learning now does a thing called feature extraction and feature selection for us, which is what we used to have to do by hand in machine learning. Now you can actually feed deep learning data, and it can actually work out what variables matter and what ones don't. So that whole preparation piece makes it it's disappearing slowly but surely. And that's important because it means that we can throw this technology at a whole bunch more problems than we couldn't before. That's why you're seeing so much inroads made in the last few years. The downside of this, of course, is deep learning generally requires a lot more data. And that's not always an easy thing to find. So hopefully that all makes sense. So I'm going to take you through something that's commonly called the machine learning pipeline. So this is literally how it works. Hopefully, if you can get this, you'll walk out of here probably knowing more than most of the population. It's not that complicated. Generally speaking, the thing that does the work for us is a thing called the model. Now, a model is just another name for an algorithm. It could be a neural network. That's literally it. So you'll hear a lot of talk in this world about the model. But the model starts off not knowing very much in this world. It's a bit like a toddler. It doesn't know anything. And just like a toddler, it likes to experiment from trial and error. And that's exactly what we do. We give it what we call training data, and we allow the model to make predictions. To begin with, the model makes crazy predictions that don't make any sense. We take a look at it, and we compare it to what it should have done. And if it's not right, we make a little adjustment, and I say just a little adjustment, and we let it predict again. And so on and so on. We keep going, comparing our prediction with what we expected, and we adjust the model. After that, we have what we should have, a trained model. So this model now has knowledge based on what we've shown it. Okay, that's all very well and good, but how do we know when we use this model in the real world, it's actually going to work with our data? You know, we want to start feeding real project data into this model and get real predictions coming back out the other side. That's where testing comes in. Testing sounds a little bit similar to training, but it's different. Whereas training, we make adjustments. With testing, we don't make any adjustments. And more importantly, we show the model data it has never seen before. So if you imagine we used 1,000 projects to train this model and it learned how the cost model worked, we would show a completely different set and ask it to make predictions. So it's completely verifiable. We can assess these predictions against what we expect, and we can work out if this model is any good at making predictions on data it has never seen before. So that's exactly what we do. Almost like training, except we make no adjustments. So now what we've got is a trained and tested model where we know the accuracy. So we can say usually this model has a loss of 5%. So it's going to be within 5% of an error on the actual true value. So then we take this and we show our problem data. So this is the real world data that we actually care about. This is about the data that we would take from projects, pass through the model, and get a prediction. So hopefully that all makes sense. We won't have to go into that level of detail, but I wanted to try and bring us all together so that what we talk about later isn't wasted. Are we going for time? Okay, so a journey in AI using projects. So the first step I wanted to take in this was classification. I had this bold idea. I thought, I wonder if it would be possible to train a neural network to actually be able to tell the difference between good projects and bad projects, but really early on. So when a project's just maybe 20 or 30% of the way through, could I show a project chart and get it to come and tell me, I think this is going to be a good one or a bad one? Pretty basic stuff. And when I first started this, I actually had to learn the new technology. It'd been a while since I'd done it before, so it was a bit new. And in fact, instead of showing it project charts, I actually showed it pictures of my daughters who look very similar. And I first of all tested to see if it could tell the difference between Isla and Iona, and it worked. So after that, I was quite excited, and I decided I was going to show project charts, and that's how this whole journey began. So first off, what is a good project? Well, my definition was a project that's cost is within plus or minus 10% of the budgeted cost and completes within plus or minus 10% of the approved schedule. So basically, it's called project classification. We're taking project charts, we're feeding them into a trend classifier, and it is literally coming back with an answer that says good or bad based on this. Now, the idea was here, we're going to feed in project charts that are in the early stage of a project, and it's got to try and guess what happened at the end of the project. So we took those raw project charts. I had to do some what they call feature engineering. I had to change the format of them so they look a little bit different. Machine learning doesn't necessarily like to look at pictures the same way we do, but it's more or less exactly the same thing, just adjusted. I fed that into the deep learning classifier. And here's an example. So if you look at this chart here, we've got a project which is 5 months in. It's not on track, but it's got a plan to get back on track. So we throw that to a classifier, and it comes back and says, bad. We've seen this one before. This 12-month project actually went 43% over budget and was 5 months late. It makes that determination because we've trained it with all the other projects it's seen in the past. So it's able to make a much more accurate assessment based on the probability of what it knows. So it's not just guesswork or gut feel or optimism. It's actually it's grounded in fact. So the result of this whole process, the classification, I tested it with 80 sample projects that I'd never seen before, and it had an error of under 10%. So that means that more than 72% of the projects were accurately classified, with around about 7 being inaccurately classified. So look, I thought that was a pretty good start. It's not groundbreaking. I didn't think this was going to break down any doors anytime soon, but I was encouraged to go further. But for me, the thing I really wanted to do, and I wasn't sure if it could be done, I wanted to do a thing called regression. So regression means basically, in this particular context, forecasting. I wanted to make a predicted forecast. So for every time period of the project, right from the present day all the way right through to the end, I wanted to provide an AI-generated forecast that would sit alongside the human-based one and perhaps counter it. So as you can imagine, once you've got a forecast, you can make all sorts of other metrics that come off the back of that. So I set about trying to complete this. And then I realized project data that I would have to use looked a bit like this. And that's actually part of the reason why we've actually probably got to this point. Project data is big data, so that's just actually plan actual forecast for 12 months, rolling forecasts, all the snapshots all the way through. And I actually spent the time and looked. The human fingerprint has actually got 1 in 10 trillion different combinations. If you take a project chart like that and you just imagine those numbers there are only, say, 2 decimal points, so between 0 to 99, you actually have 1 times 10 to the 27 different combinations across a grid like that. That is a huge signature analysis. It was a good thing and a bad thing. It meant that every project is very much a different project, but it also meant that there's a lot of data to crunch. So I decided to set about training a regression neural network. So I take all the historical project cost data, so it's all time series data, and I applied what they call feature engineering. So this time, like before where we changed into different pictures, this time it's very much numerical. There was a lot of different transformations had to take place. And I would be honest, that's probably where most of my IP resides. That process is something that takes a fair bit of research, and it's non-trivial, so to speak. So unlike before, it was a classifier. This time we feed it into a deep learning regressor. So the good thing about this time is because we're actually producing numerical data, we've now got the type of information we can use to create a completely predicted dashboard. And that's what happened. So we took a snapshot of the projects in execution, so taking projects at 20% or 30% or 40% of the way through execution, feeding them into the trained deep learning regressor, and actually building a dashboard which gives us a full prediction of what's probably going to happen. And just not that project, but the whole portfolio in general. Okay, so how well does AI perform? Well, we validated the test performance. I fed it 38,000 project snapshots at progress mark 20, 30, or 40%. It's probably worth this point explaining how do you get all that data? A few people have asked me, how do you get this data? And I was certainly dealing with data sets. I was trying to put this thing under pressure, and I was certainly testing it with things like 300,000 projects. When you get to deep learning, you don't generally follow the same processes you do with machine learning. When you get real-world data, you certainly use that real-world data, but you also use it to generate what they call augmented data. So say I've got a project which is running 150% late, but I've also got other projects looking pretty similar at 100% late. It's reasonable to assume that just because you've not seen projects between, say, 120, if you can do 100% late or 150% late, chances are you can do 120% late. So you hold stable the project data, and you change it for all those little differences in performance. So you actually, if you like, multiply the data with all the probabilities of what could possibly have happened, given the fact that you've seen things between both those edges. And that allows you to actually test it across a huge amount of data, and it's very valid to do that. So at 38,000 project snapshots, it was 20%, 30%, and 40% mark. It had a unique combination of plan type, total cost, and duration. and also a unique combination of CPI, SPI, and different types of forecast performance. So I literally tried to throw every single thing I could think of at this. I made it as nasty as I could. I had delays in the middle of plans. Those plans were ugly. So the results? Well, across that whole data set, I found a prediction error of 7.5% on cost and 4.7% on time. So what do I mean by that? Well, we could accurately, across 38,000 projects at 20%, we could actually predict what the final cost was going to be to within a 7.5% error, and how long it was going to take within a 4.7% time. Now, I was actually quite delighted with that. It looks pretty good. I've since found there's certainly boundary conditions or edge conditions where it might not perform as well, especially if it's seen something that's a complete black swan event. So I wouldn't try and say it's completely foolproof, but as it says down here, for 81% of the predictions, they were more accurate in the forecast. So it doesn't beat the forecast every time, but it beats it most of the time. And the prediction was better on average by 15% over the forecast. So, for instance, if you had a forecast accuracy of around about 20%, well, we were sitting around about 5% in terms of its error rate. Interestingly, to not throw too much data at you, I've not got the 20, I'm not showing the 20, 30, 40%, but as you'd imagine, as you go further through the project, it gets more and more accurate because you've got more data to draw from. But here's the interesting thing. The improvement over the prediction stays the same, because even though the prediction gets more accurate, the actual forecast gets more accurate, so they stay the same distance. You'd expect so, right? As you get further through a project, it gets harder and harder to hide the truth, or if that's the case, or it sometimes gets easier to determine what's going to happen because there's more behind you and less in front of you. And yeah, so look at that seemed like a pretty firm basis to proceed and go further. And it was actually at this point here when I seen these results, I actually decided to launch my own organisation, and I formed a startup company. So probably the important thing is, well, how can we apply this in the real world? And the one thing I really wanted to take away here, I didn't want to just throw another bunch of AI solutions. It's important that we actually can practically apply this to make a difference. So let's just look at this 12-month project, right? So you get 12 months, you're 10 months in. You've got 2 months remaining. Just imagine, and look, this isn't this unrealistic, right? I don't know how many times you've noticed it, but generally when a project's going to go wrong, no one comes and tells you 3 months in that, by the way, we think this is going to be a bad one. You generally find out a couple of months before the end, it'll be near another 6 months, and it's going to cost a whole bunch more money. You've now got a 2-month recovery window. So if you're going to pull this 8 months worth of work back in, you've got 2 months to do it, because that's when you found out about it. What would be more useful is that 4 months of the way through the project, you had a prediction that told you, do you know what, you're probably going to take about 6 months longer on this project than you expect, and you're going to need a couple of $100 million more. Now you've got an 8-month recovery window. That's what improved predictability gives you. It gives you the opportunity to take corrective action, because if you don't know you've got a problem, you can't fix it. And the earlier you deal with a problem in a project, the less expensive it is, because you've generally got more options. So look, I talked a little bit about a dashboard. So this is our prototype dashboard here. And look, I'm just going to run a little video rather than try and do it live, and just show you some of the things that you can do, because it seems pretty simplistic, but when you actually step right into it, having another variable that counters the forecast, it really gives you some powerful insight. So if I step inside this portfolio here, you can see you've got a current status indicator, a forecast, but now you've got a predicted status indicator. So it's looking forward into the future and telling you what the prediction sees, and it's not good in this case. You've got a monthly variance, actual versus forecast, but now you've got an actual versus predicted. You can track, and similarly, year-to-date variance, actual versus planned, but also actual versus predicted. You can start to track how well you're going against forecast versus your predicted. Then you can look at that completion figure and decide what one should I be looking at here, the forecast or predicted one. So similarly, if you look at the periodic and then the cumulative charts, you've got an extra line. You've got a predicted line. So you've got your forecast, plan, and actual, but you've also got predicted bars as well there. So the whole way this application works is it's kind of responsive. If you click on a part of a chart, it takes you to a filtered list below. So you can see you've got forecast cost variance, predicted cost variance, forecast schedule variance, but predicted schedule variance. So you've got a predicted version of nearly everything you've got a forecast version for. And this is where it gets really interesting. So that's just an example, a slice and a list based on a status. If we go into the forecast cost variance, you'll actually see that most of these projects plus or minus 10%. 14 of them are shown to actually be finishing within plus or minus 10. It looks pretty good. So we filter that list, and then what we do is we go into the predicted cost variance, and we look and we see actually, but out of this list, there's quite a number of them are still predicted to be minus 30 to minus 10%. Let's filter that list, and now we've got what you could call a list where there's a disagreement between the prediction and the forecast. And you can step inside that, and you can start stepping inside projects and start seeing, why does the prediction disagree with my project here in terms of the forecast? Look, it's an opportunity to, if you've got a portfolio with hundreds of projects, you can really quickly drill down into the ones that you need to look at. And that was my intention with all this. I don't, for 2 seconds, think the AI is going to cover all the different cases. It certainly won't. But if you can get to a situation where 80% of this is kept under control, and you've got something else watching for you, it means that you can put your focus on the areas where things aren't looking so good. So if I kind of get towards my kind of conclusion, really there's challenges and there's opportunities. So let's step into the challenges first. So a big challenge in this space is security. And this data is sensitive data, obviously, but most organizations now want these type of applications to work as software as a service. It's a preference between a lot of organizations. A lot of them are mandating it. They don't want to host applications. They don't want applications. They want a service running in the cloud. Add to that the powerful supercomputers that crunch this type of data. They also live in the cloud. So right from the start, you're having to ship data from a client's premises to your own, to the cloud, back and forwards again. As I've learned, security is not something you can just bolt on. You have to literally consider it every single step of the way. The minute you think about doing something, or a client asks, can we do this? The first thing you've got to think of is, how do we encrypt it? How do we decrypt it? How does it go from here to there and never live on a disk? It's a non-trivial thing. And if you're ever dealing with someone and they're not asking those kind of questions of you, then you should be asking them. Closely related to security is desensitization and privacy. It is definitely a little bit different. This data, it's got people's names, it's got project names, it's got department names, it's got company names. Relying really heavily on security is putting all your eggs in one basket. It's hoping that data never gets seen by someone else. A much nicer space to be in is if you can desensitize the data in the first place. And that actually can be done. You can go through this data and you can change it. It doesn't need to be Project Manager Smith. It can be Project Manager A, B, C, D, E. Similarly, you can do that with organizational names, company names, even the numerical data. You don't need to keep your numerical data sitting in billions of dollars. You can scale it right down to numbers that mean nothing. I'm putting a lot of effort into this space because I think it's something that's really powerful. If you can actually get the data in a format where it doesn't matter if it leaves, the whole world sees it, you're in a good space. This area is getting led by the healthcare world because a lot of machine learning is getting done on patient records, and as you can imagine, that's extremely sensitive personal data. So a lot of the work that's getting done in this space is getting led by that area. But I see myself borrowing it and using it in the project world. The other part down here is data availability and quality. More data is always good, but along with more data tends to come more bad data, and that's not a good thing. Because, like most computer systems, it really is garbage in, garbage out. You've really got to guard what you train your model with. If that model gets any garbage projects in there, it's going to make garbage predictions. So you really have to be careful and make sure you're using high quality data. And to be honest, it's better to create synthetic augmented data that in the fashion I discussed earlier than it is to get more real data that could be of dubious quality. So the whole, is it real data, synthetic data, augmented data, it's actually not a black and white issue. It's sometimes better to actually create data that's probable than it is to use real data that's unrealistic because it's poor quality. And the last point here is cost benefit and customization. So this is something I recognised. It's half a technical problem, half a business problem. And actually, I've had people ask me about it today when I've been on my stand. So obviously, the more information you learn, the better your predictions are. So if you go in and you start learning, how complex a project is, what time of year it was delivered, was it the wet season, whereabouts it's been delivered, what organisation delivered, what team delivered it, is this team generally not as good as delivering these projects as another team? If you throw absolutely everything at it, you can make extremely accurate predictions, wildly accurate. But that actually requires a lot of effort on the client side and a lot of effort on the Bitwinder side, because you actually have to make an extremely customised model. And from a business perspective, it's not good because it breaks your business model, because now what you've got is you're solving 100% of the problem for one person. You can't scale it out, and people want it scaled out because they want the cost kept low. So the deeper you go with this, the more expensive it gets and the less value for all the clients. So that's something I've discovered. Interesting enough though, there are some mega projects, and I've been approached by an organisation in this case, where the problem is so big, the dollars are so big, that it just doesn't matter. Just give us a prediction, and we want the most accurate one we can get, because an uptick of 1%, it could be $100 million, right? So it's really is a specific situation of the cost benefit of customisation. So that's something which I've been learning along the way. Quickly just start to wrap up here. So where to from here? Well, I want to improve the explainability and the drivers behind the why. So at the moment, we can verifiably prove that these predictions are accurate, but what we really want to do is, okay, that's great, but why? And that's a question I've been asked of for a number of potential clients when we've been discussing it. And look, it's not a trivial matter. You'll hear explainability talked about in artificial intelligence quite a lot. The reason being, it's actually really quite difficult. But there are a lot of new techniques coming out that are actually helping to address this, but it's a moving space. Schedule risk and contract deliverables. Look, I've got my eye on trying to expand this past where it's at the moment. I don't know how many times I would have looked at risk assessments for projects that look completely different, and they're more or less a carbon copy of the last project, right? I can see a world where we review risk assessments, we look at the patterns within them, and we also cross-reference that with the complexity of the schedule and ask a question, why does this risk assessment look just like the last project, even though the projects look nothing like each other? So there's a lot of opportunity to actually start dealing with deliverables. Similar with contracts as well. And then finally, I think the next step, and look, I'm an engineer and a project person. I've worked with plenty of project controls people. I'm not a project controls person myself. So I'll have to I'll let you guide me on this. But, I've seen a big move and an increase in the quality of what we see as visualization. So, 10, 15 years ago, we're still dealing with spreadsheets and PDFs. Now we've got Power BI, and we've got Tableau, and we've got that into databases, and it's all unified, and we've got a single source of the truth, or at least we're getting towards that. I think that's wonderful. I can see another evolution past this, where we actually should be providing context-sensitive data, where the visualization is developed based on the personality and the personal preferences of the person, but also in the meaning and the content of the data. So if someone really doesn't like something a certain way, but the message coming through that information isn't looking good, let's present it in a way that we need them to see based on who they are, what their role is, and what the message is coming out from the data. So at the moment, we've got a kind of demand-based model where we can go in and we can say, hey, slice it this way. It's almost become your burger, your way. You can slice it any way you want. What would be really nice is if we can learn how people like it and present it in a way where it actually looks more like what they want to see. So look, I never invented this idea. It's something that's already beginning to happen. So look, that nearly brings me to a close today. I'll take some questions in a moment, but look, I'd just like to put a kind of call to action out there. Obviously, we are doing a lot of research in this space. It's still something that's moving forward. I would be the first to admit we don't have all the answers, but we do recognise that we've definitely shifted things forward in a big way. But we're keen to work with research partners who want to come on a journey with us. So I'm not necessarily just talking about prospective clients. I'm talking about people who want to test out the technology. It helps me and it potentially helps them as well. So if you think that's you, please get in touch. I try my best to be as easy to work with as possible. Okay, listen, I really appreciate your time. And I'd just like to kind of draw my presentation to a close there and take your questions.
Hi, Peter Major from Pledge Consulting. Really interesting presentation, thank you. So it's interesting that you focused on cost and schedule there as a couple of the dimensions. And I'm interested in one of the other key levers, which is scope. So is there any assumption of like-for-like scope being delivered against your predictive model? Or is there an assumption that that's the maximum scope? Or what are your comments there?
So if I understand your question properly, we're talking about, we might have cost or schedule data, but how do we know it relates to a project that's similar in terms of the similarity in terms of scope? Absolutely. So that leads into that cost-benefit situation. So where you actually classify projects based on type, so similarities of scope, you can get much more accurate. if you don't even use scope and you literally just use cost and time data, you get the values I showed you there. So that was without that. It only gets better with that. The reason, and it's been hard for a lot of people to get their head around. People say, but hold on a minute, how can you possibly learn from project A and apply it to project B when they're different projects? It's because we're not really talking about projects. We're actually talking about human behaviour. You're doing a comparison of, if you think, this is how I like to think about it. Your plan is what you said you were going to do before you started. Your actual is a record of what you actually did. You can't get out of those two things. They do not change. The actuals are coming whether you like it or not. The forecast is where the human part becomes. You get an opportunity to change that forecast. Now, your forecast is an indication of how good you are at learning from the past. Now, if you don't really have a handle on what your own project is, it shows up. So you can't really get out of it. So it's really a measurement of human behaviour rather than projects. But the more you go into the project world, the more specific it gets. And certainly on big, if anybody wanted to use this on a single project that was sitting above the 50 million mark, I certainly wouldn't do it without that information because it's just getting too different.
Thank you very much for that presentation. It was very interesting. Can we apply that same sort of thinking to the stakeholder who's receiving this information perhaps for the millionth time themselves and is refusing to believe it? Can we present them something with saying, we've already worked out that there's a 50% chance you're not going to believe what you're reading?
Yeah, so absolutely. You know what? That was the bit that caught me by surprise. When I first started this, I thought to myself, and I've got a few colleagues in the room here, I think the people I work with might hate me if I make this. And because, I was in there with other managers and we don't always get it right? I'm part of the reason, I'm part of the problem. And that's why I recognise the opportunity. And but the thing that really surprised me was actually the project management community and the project controls community. They received it really warmly. And because quite often, it's not the fact that we don't know what's going to happen. I tend to find actually a lot of the reports are actually quite accurate. It's like you say, when you present it to stakeholders, they dispute it and say, well, we don't believe that. That number doesn't work for us. And somehow, slowly but surely, that number gets adjusted before it gets to the decision maker. Whereas I actually heard a number of project managers saying, we love this because this actually gives us something we can go and say, well, you know what, you might not believe us, but you're actually better. And I provide a probability figure. So if you know the data set's sitting around about 1,000 projects, you can generally say, like 756 projects here disagree with you, but feel free to be the one that made it. Chances are you're not going to so you actually get a chance to have a conversation you've never had before, because at the moment it's pretty disputable. But if you've actually got something that can draw on that previous data, you've actually got a chance to have a real conversation. And like if someone asked me, what's your value proposition? I was actually saying, look, it's probably cultural change, because it's probably not about projects. It's really steeped in people and more than anything. It's about giving people an opportunity to sit in front of a decision maker and say, look, I know you don't like it, but this is what history's told us and we're heading in the same path. So I think you've really hit the nail on the head.
Thank you. That was a fantastic presentation. Just a quick question is, if an organization was to come to you and want to apply this, do they need to start the data collection from scratch, or can they leverage the data that you've already tested?
Yeah, look, a really good question. Look, you can, using the augmented data I've already got, you could literally start testing it without providing me with any data, and we could quickly see how good what we've got is a match for what you've got. I'd like to think I'm almost certain it's going to be better than the way we do it at the moment, even without any of their specific data. But the more data we can collect from an organisation, the better it gets. But we can characterise it, so we can actually analyse a small number of projects and look at the different bounds of performance amongst it, and we can actually develop a much larger wide range of data. I should explain a bit what that means. Imagine you've got a 12-month project and it goes late, it ends up 24 months. And then you've got another project, looks just the same, and this one goes 18 months. It'd be kind of silly for you not to consider if you had one at 24 and one at 18, you could definitely have one at 19. And you could have one at 20, you could have one at 21. And you don't want to make a poor prediction just because you've never seen it. You don't want to have to live every single mistake yourself to build your data set. In fact, the idea is that you start living less mistakes. So yeah, so the data thing, it's not as simple as it seems. So if you've got a small amount of data, you can definitely start working with it. Big data, great, more work, but small data also works.
Hi, absolutely great presentation. The question I had, when you're processing it, how long does the processing take? I mean, it obviously changes between complexity of projects, but is it relatively real time, or is it days, weeks?
So do you mean, okay, so when you, yep, so when you build the model the first time, when I was doing this before I was using these really powerful computers in the cloud, the data set got that big that sometimes it was taking weeks. Literally weeks, the computer was running full bore to try and do these calculations. I moved to the cloud and then that becomes an hour. That's the training of the model, that's a one-off. The good thing about machine learning is training is extremely computational, prediction is not. Prediction is really fast, prediction is like milliseconds. So, but there's the cloud's a funny place. It's not like it used to be where you just had a server and you host it. These days things spin up and spin down and they bill you based on how often it's used. And you know, it can be really tailored to the client. If the client wants 100% availability and just clicking it straight away, you can definitely make that happen. If it's something they're only using infrequently, you know, it doesn't cost me either way. I would suggest that, you know what, if you need to hit it once a month, you can significantly reduce your cost if you're willing to accept like the first time you hit it, a couple of second delay, and then after that it'll be like milliseconds for the next 24 hours. You can change it any way you want. But the actual, there is no computational load on a prediction. It's just on the training. It's a good point, because if it was, it wouldn't be, that would be a game over, right? It wouldn't work.
Yeah, g'day Alan. I've got two questions. I'll try and remember both of them. The first one that I've got is, do you see this getting applied to like the class 4 estimates, the class 3 estimates, or this is just before execution? That's the first question. And the second one. The second one is actually, yeah, how would you actually implement it? What data are you taking? Are you taking like the budgeted number? Are you taking like a lot of details? Because I'm just, yeah, those are the two questions.
Okay, so yeah, look, someone said this to me a number of times. People have said to me, if you can make this work for estimating, you're off. And look, there's a reason why I never went there. I looked at the space before I started and I thought, there's a lot of things in that space. There's people who've got benchmarking businesses, and there's Monte Carlo. But look, how I see myself fitting in amongst all this is I looked at those different methodologies and I thought, well, you know, they're all doing something. And I'm a big fan of iron value management. I like Monte Carlo. I think they're all good. But this is doing something different again. It's actually learning from the past, whereas those tools don't do that. I actually think it could be done. And look, I'll be honest, it is my game plan to reverse my way back into that. But it's definitely a bit more complex, because you're going to have to gather a lot of data, because you literally start having to benchmark yourself now against other projects. And look, I actually think it's the best, I think machine learning is probably the best approach to do it. But I actually think it would have to be client-led, because I'd be interested to know, like, I've never tried it. I think it's completely possible. But just like you said, the data requirements would be of interest, because, you know, with execution, it's about human behaviour. I've got live data that keeps happening every reporting period. So it continually generates me new data. That's how I'm able to make the forecast predictions so accurate. But before estimation, you've got no live data. You've only got a study. You've got historical data, what we've done in the past. I suspect that I think it would fall into that ballpark of that customization. I don't know if you could roll out a product that would be software as a service that would deal with the mass market. I think certainly for the big projects, you could study them extremely deeply, and you could use machine learning to try and extract the variables of interest and they call it transfer learning, transfer that over to another project. And the beautiful thing about deep learning is it will automatically drop the variables that don't matter, and it will home in on the ones that do, and it will give you a prediction. So there's no doubt about it. It can definitely be done for estimating, but it'll be quite different from what I'm talking about. It won't be light touch data. It'll be pretty high. And I'd expect, look, the beautiful thing about this is you can verify it. You could build a model, you could try it, and if it's garbage, it'll just come back rubbish. And you can test it and test it and test it, and eventually you get to a point where you're actually getting really good estimates. You're home and dry. So that's a beautiful thing about this technology, is you can actually prove if it works or not. So like, I think it's the future. I think it's much more complicated than what I've currently done. And I'd love to get a piece of that, but I suspect that market's a bit more congested. And as a startup, from a business perspective, they say don't go and take on the big. You go and take on the big people straight away at their main game. They're going to be taking notice of me a bit too much. So yeah, does that answer?
Yeah, no, it's good. Just wanted to expand. Like, you can benchmark something, but this here is great. You know, like you say, this is going to go up 40% tells us, it gives people really open eyes to go, you know what, maybe we need to get our budget, you know, maybe our threshold budget or something, you know.
Well,
look at,
one thing you could do right out of the box, you could do tomorrow, right? This would already do it. Say every time you had if you almost did what Grattan Institute did, you looked at your estimate before you started and you looked at your completion and you looked at the attributes of that type of project, so the complexity, the location, the discipline, is it mostly structural, civil, infrastructure, who knows, all the way through and classified it and then compared it to how much it costs at the end of the day, you could do that straight away, right? That's something you can do instantly. It would just be knowing what are the variables of interest, what are those things you need to map, what are the things that are causing, you know, to blow out. So, yeah, look, it's exciting. The problem is the problem space is just too big. There's actually too many things to try and solve. Any more questions? Cool. Well, thank you very much for your time. Appreciate it.